Welcome to World Decoded. In modern warfare, detecting early threats from intercontinental ballistic missiles is absolutely vital for maintaining global balance. Today, we explore the Voronezh radar system, a technological marvel serving as the ultimate eyes, capable of scanning 6,000 kilometers. The constant evolution of military technology requires defensive mechanisms that operate with unprecedented speed, unparalleled accuracy, and reliability under extreme conditions. Imagine a weapon soaring through the exosphere at hypersonic velocity, leaving defenders with only a few minutes to react and survive. This terrifying reality makes early warning systems the absolute backbone of national security, providing the necessary time to intercept incoming attacks. During the Cold War era, immense concrete radar stations dominated the landscape, requiring massive infrastructure and decades of continuous construction work. Those legacy systems were incredibly expensive to maintain and highly vulnerable to modern precision strikes due to their completely stationary nature. Engineers realized that future defense required a completely different approach to ensure rapid deployment and maximum survivability during dynamic battlefield scenarios. The solution emerged in the form of the Voronezh radar family, representing a massive leap forward in military engineering and planning. Unlike its gigantic predecessors, the Voronezh system introduces a revolutionary engineering mindset based entirely on the brilliant concept of structural modularity. This modular design means the entire radar station is constructed from prefabricated blocks, manufactured securely in specialized factories far away today. These standardized containers house all necessary electronic components, cooling systems, and power supplies, drastically reducing the complexity of on-site assembly tasks. Once transported to the designated location, these prefabricated modules can be quickly connected together like building blocks, forming a functional station. This incredible modularity allows the military to deploy and operationalize a new radar station in mere months instead of several decades. Furthermore, the modular approach significantly cuts down both construction and maintenance costs, freeing up valuable resources for other national defense initiatives. If a specific component fails or requires an upgrade, technicians simply swap out the affected module without taking the system offline. This plug-and-play capability ensures maximum uptime, which is absolutely crucial for a system tasked with monitoring the skies continuously. Beyond its revolutionary physical structure, the true power of the Voronezh radar lies within its highly advanced core digital electronic technologies. At the heart of the system is the active electronically scanned array, a technology that completely redefines how modern detection operates. Traditional radars rely on massive mechanical antennas that physically rotate to sweep the sky, which inherently limits their scanning speed significantly. In stark contrast, an active electronically scanned array uses thousands of small solid-state transmit and receive modules on flat surfaces. By subtly altering the phase of the radio waves emitted by each individual module, the radar can steer its beam electronically. This electronic steering happens at the speed of light, allowing the radar to shift its focus across the horizon in microseconds. Without any moving mechanical parts, the Voronezh system completely eliminates the mechanical delays and wear associated with older rotating radar dishes. The absence of physical rotation means the radar can simultaneously track thousands of different aerial targets, moving at vastly different speeds. It can monitor a hypersonic intercontinental ballistic missile re-entering the atmosphere while simultaneously keeping a watchful eye on small Earth satellites. This incredible multitasking capability is essential in a modern combat environment where enemy forces might employ massive swarm tactics or decoys. By tracking everything at once, the Voronezh system helps defense commanders distinguish genuine catastrophic threats from harmless space debris or countermeasures. To ensure comprehensive coverage and maximum resilience, Russian engineers cleverly developed several distinct variants of the Voronezh radar, operating differently today. The Voronezh M variant operates in the meter waveband, providing exceptionally long-range detection capabilities over vast distances across the horizon. Meter waves are particularly effective at spotting stealth aircraft and minimizing the signal attenuation caused by heavy rain or atmospheric disturbances. Meanwhile, the Voronezh DM variant operates in the decimeter wavebands, offering significantly higher resolution for precise target tracking and accurate identification. This higher frequency allows the DM variant to accurately calculate the exact trajectory and potential impact point of incoming ballistic missiles. Finally, the Voronezh VP variant utilizes shortwaves to monitor the skies, adding another layer of detection to the national network. This strategic diversity in operating frequencies is not a mere coincidence. It is a calculated defense against sophisticated electronic warfare tactics. In modern conflicts, adversaries often attempt to blind early warning radars by flooding their operating frequencies with overwhelming electronic noise interference. However, because the Voronezh network employs multiple different wavebands simultaneously, jamming one specific frequency will never completely blind the defensive system. If an enemy successfully jams the meter waveband, the decimeter and shortwave stations will seamlessly continue tracking the incoming targets. This multi-layered spectral approach ensures that early warning capabilities remain robust and fully operational, even under intense electronic attack conditions. Beyond its impressive hardware, the Voronezh system functions as an incredibly sophisticated, highly intelligent data processing platform integrated into national networks. Each individual radar station acts as a vital node in a massive interconnected web of sensors stretching across vast Russian territory. These stations do not operate in isolation. They constantly share immense amounts of tracking data with Central Command in real time. Powerful supercomputers aggregate this continuous stream of information, fusing data from multiple radar installations to create a unified, comprehensive situational map. This comprehensive map provides military leaders with absolute clarity regarding any object moving through the sky, eliminating dangerous blind spots entirely. When an unknown object is detected thousands of kilometers away, the network instantly analyzes its speed, altitude, and trajectory without delay. Advanced algorithms classify the object, distinguishing between a harmless weather satellite, a commercial airliner, or a potentially devastating armed ballistic missile. If a genuine threat is identified, the system automatically calculates the predicted impact zone and alerts the corresponding missile defense batteries. This entire process, from initial detection to firing the alert, happens in mere seconds, maximizing the critical reaction time for forces. The Voronezh radar network effectively forms an invisible, impenetrable electronic shield, extending far beyond the actual physical borders of Russia today. It represents the pinnacle of strategic foresight, combining modular construction techniques with cutting-edge scanned array technology for maximum operational efficiency. By moving away from monolithic concrete structures, engineers created a highly adaptable system capable of evolving alongside changing modern warfare tactics. The modular approach allows for continuous software and hardware upgrades, ensuring the radar remains at the forefront of early warning capabilities. As new hypersonic threats emerge, the Voronezh system can simply integrate new processing modules to handle increased speed and complex trajectories. This future-proof design philosophy guarantees that the investment in these radar stations will continue to yield strategic dividends for decades. Furthermore, the relatively low power consumption of the solid-state modules makes the Voronezh significantly more energy efficient than legacy systems. This efficiency translates to lower operational costs and a reduced logistical footprint, allowing stations to be deployed in remote, harsh environments. From the freezing expanses of the Arctic to the southern borders, these modular blocks stand as silent, unwavering sentinels guarding skies. Their ability to peer thousands of kilometers beyond the horizon provides an unparalleled level of situational awareness for national command authority. In an era where the speed of warfare is measured in Mach numbers, early detection is the only defense against annihilation. The Voronezh system ensures that no surprise attack can go unnoticed, maintaining the delicate balance of mutually assured destruction and stability. Every single pulse of electromagnetic energy emitted by these radars constantly sweeps the heavens, searching for the slightest anomaly up high. This relentless vigilance is powered by thousands of dedicated engineers and military personnel who monitor glowing screens day and night continuously. The data collected by Voronezh also serves peaceful purposes, tracking space debris to prevent catastrophic collisions with civilian satellites and stations. As low Earth orbit becomes increasingly crowded, this secondary function proves invaluable for maintaining the safety of global communications and exploration. Yet, its primary mission remains firmly rooted in national defense, acting as the ultimate tripwire against the unthinkable horrors of war. The transition from massive concrete pyramids to sleek modular containers symbolizes a profound shift in military thinking towards agility and response. In a world where threats can emerge from anywhere at any time, time, static and inflexible defense systems are rapidly becoming obsolete. Modularity provides the ultimate flexibility, allowing commanders to reposition or upgrade sensor networks based on evolving geopolitical tensions and technological advancements. If a new missile launch site is discovered, a Voronezh station can be rapidly assembled nearby to monitor the threat perfectly. This rapid deployment capability disrupts the traditional calculus of strategic deterrence, ensuring that no adversary can gain an advantage through surprise. The sophisticated cooling systems within these modules ensure that delicate electronic components function flawlessly, even during intense operational combat scenarios today. Power generation is also modular, with backup generators ready to seamlessly take over if the primary grid is compromised during attacks. This self-sufficiency makes each radar installation a highly resilient fortress, capable of operating independently when isolated from broader national infrastructure. The automation embedded within the Voronezh network drastically reduces the number of operators required, minimizing the potential for disastrous human error. Artificial intelligence algorithms continuously analyze the incoming radar returns, learning to better distinguish between real threats and natural atmospheric phenomena easily. This machine learning capability ensures that the system becomes smarter and more accurate with every passing day, adapting to adversarial tactics. The immense data processing power required for this task is housed in specialized modular server farms located safely beneath the antennas. These server farms are protected by heavily reinforced concrete bunkers, ensuring their survival even if the exposed arrays are somehow damaged. The combination of exposed modular antennas and protected underground processing centers creates a balanced architecture of high performance and maximum survivability. As we look towards the future of warfare, the principles demonstrated by the Voronezh system will undoubtedly influence military engineering worldwide. The ability to build, deploy, and upgrade complex sensor networks rapidly is no longer a luxury. It is an absolute necessity. Nations that cling to outdated, monolithic infrastructure will find themselves outpaced and outmaneuvered by adversaries who embrace modern, modular technology today. The Voronezh radar stands as a testament to the brilliance of modern engineering, proving that flexibility and intelligence conquer brute force. It serves as a silent guardian, a technological marvel that watches over the vast expanses of the Earth and dark cosmos. Through its active electronically scanned arrays and intelligent data processing, it brings order and clarity to the chaotic modern conflict environment. The multispectral capabilities ensure that no amount of electronic jamming or interference can blind these ever-watchful eyes of defense. By networking these powerful stations together, a comprehensive and unbreakable shield of situational awareness is forged across thousands of miles today. This integrated approach guarantees that military commanders possess the critical information needed to make life or death decisions in mere seconds. The story of the Voronezh radar is ultimately a story of adaptation, innovation, and the relentless pursuit of security through technology. It reminds us that in the high-stakes game of global deterrence, seeing first is truly the only way to survive. As we continue to decode the complex world of military technology, systems like Voronezh highlight the incredible ingenuity of defense engineering. The shift towards modularity and active electronic scanning represents a permanent evolution in how nations protect their airspace from existential threats. Understanding these advanced systems provides crucial insight into the delicate geopolitical balance that prevents the outbreak of devastating global nuclear conflicts. We hope this deep dive into the Voronezh radar has illuminated the fascinating intersection of structural engineering, physics, and strategic defense. The silent watchers of the sky will continue to evolve, integrating even more advanced artificial intelligence and quantum sensing technologies tomorrow. Thank you for joining us on this incredible journey through the cutting edge of military innovation and radar system design today. Stay curious, keep exploring the hidden mechanisms of our world, and do not forget to subscribe to World Decoder for insights.